Hi everyone, welcome to the regression analysis lecture. This is one of the subjects in the Statistical Science Study Program, Department of Mathematics, University of Indonesia. So for this session, we still be continuing with the topic on model building. Previously, we've done modeling on quantitative variables with one predictor and with two predictors. Okay, now we will see briefly model building for more than two quantitative predictor variables. Okay, so just having the one that we have before, that is for two variables, we have this kind of model. Let's say now we have kind of like three variables. Okay, so in that case what we have here is that our model will be just beta 3 x 3. Okay, this is just the template standard model, but then later, just following the explanation in the previous topics on two variables. Okay, you should watch the video on these two quantitative predictors. So if we just think there is no interaction at all, and then just the first term for each of the variables, then we should just put this simple first order model for all of the variables. Okay, now if we think that again, please refer to the videos on two quantitative variables. If we have the interaction term, then we start to consider second order model, and here we put in two variables, we put x1 and x2. Now what if we have x1, x2 and x3? So then all possible interactions that might be put in the model is that all combination of those three variables. So that is x1, x2, we have x1, x3, and then we have x2 and x3. Okay, and then we just need to add, okay, this is beta 3 here, so we have here beta 4, and then here we have that beta 5. Okay, so that's what you need to put in case you think that all the three variables, okay, here we should put in, okay, I haven't put beta 3x3 here, so then this one should be beta 4 x1 x2 x1 x3 and x2 x3. Okay, so this is like a complete model with interaction, considering three variables. Okay, but then we've learned in model selection and that kind of things that probably you don't need to put this all, you just need to put the terms that are really contributing significantly on the model. And how to decide on that, you just need to look at the videos on model selection. Okay, so then if you want to put in like second order model but with no interaction, then what you need to put in here is that, okay, here we have beta 2 x2 plus beta 3 x3 x1 squared x2 squared, and then here of course we have plus beta 1, 2, 3 should be here beta 4, x1 squared, beta 5, x2 squared, and then beta 6, x3 squared. Okay, so this is a second order model. All the quadratic terms for each of the variables are included, but with no interaction. Okay, if you want to have a complete second order model, then we need to consider, oh, there's no plus in here. So then we need to consider this model. Okay, So this is a complete second order model, beta 1, x1, x2, x3, x1 squared, x2 squared, x3 squared, and then put the interaction, all possible interaction, x1, x2, x1, x3, and then x2 and x3. Okay, so here we have beta 5, 6, then next we will have like, okay, here we have beta 7, and then here we have beta 8, and then here we have beta 9. Okay, so this is called a complete, this is called a complete second order model for three quantitative variables. Okay, but then again, uh, um, remember for our parsimony principle. Okay, so probably you don't need to put in all of these terms, just put in something that is, contributing really well in predicting y. So the parsimony is that simple but accurate. Okay, so we need a simple model, but then as accurate as possible. And also remember about our second principle, that is hierarchical. So the hierarchical principle is that once you put in the higher order term in here, that the lower term should be included no matter what. So it means that you can't just have the model. So for example, you can't just have model like this, okay, x1 squared, and then this one is missing, so just beta naught, beta 2x2, beta 3x3, and beta 4x4 squared. So this kind of model is not okay. Okay, so this kind of model is not okay in the sense of hierarchical way of model building. Okay, once you have x1 squared, then you have to put x1 in here. Once you have, for example, order 3, you have x1 cubed, then you have to put x1 squared and x1 in your model. Okay, so again, as you can see here, there's for 3 variables. If you have 4 variables in here, then for the interaction, all possible interactions here is that, okay, if we have that, here we have beta, oopsie, we have beta 4x4 here, then all possible interactions here is that you have to put x1, x3, sorry, x1, x2, x1, x3, and then here we have, like, for example, x1, x4, and then we have x2, x3, and then we have x2, x4, and then we have x3, x4. Okay, and then with the corresponding regression coefficient. Let's say this is beta 6, this is beta 7, this is beta 8, and this is beta 9. Okay, as you can see, when you trying to put a higher order model, and then your variables are quite many, then your model will become complicated really fast, more parameters to be estimated. Okay, so statistically speaking, you consider all the interaction terms. These are all the combinations you should input in there. If you consider complete model, then all the quadratic for example, complete second order model, then you should consider all the quadratic terms and all the possible interaction terms in that. But then again, remember our two principles here, parsimony and hierarchical. Okay, and the last message, takeaway message that you should remember is that, okay, this is the ideal way of trying to consider all possible explanation or all possible relationship, but still, to avoid the more complicated model, try to do your visualization first, just like what we did before. Please refer to the previous video. So then not all of these terms are included in the model. Okay, so that's our model building for more than two quantitative predictor variables.